Hi again, welcome back. I think this week's a really interesting topic. We're going to focus this week on learning. I'm assuming this is a topic that's of great interest to you as well, because you've dedicated the rest of your life to being teachers. And the purpose of being a teacher is to make learning happen. So learning is your core business, the main thing you're about. And in this course, we're talking about learning mathematics. So hopefully this week it really challenges you on some of these things, that you really think deeply about what is learning and how can I help students learn in mathematics. In this week's, I haven't put any links to any YouTube clips or follow-up things. I've just posed some questions because I really would like you to take time to think about this. And the reason it's so important is this is the core business of your job. This is what you'll be doing for at least your career as a teacher until you change something else. It's all about learning. So I hope these ideas are interesting for you. I hope they're a bit challenging, and I hope they get you to think deeply. Because as I said last week, the key thing we know about education that makes it happen, that makes learning happen, or does it or otherwise, is you as the teacher. You are the critical factor. So while we're interested in the curriculum, while we're interested in planning and resources and activities and idea, the most important thing about students learning in mathematics is you as the teacher. So here's my first question. Given that you've spent 12 years as a student at school doing learning, and you've spent at least 2 years already at university studying education, you probably already know the answer to this question, but what is learning? And maybe at the moment you want to stop and take some notes about what you think it is. What is learning? What do you think? Here's some definitions I've heard. A couple are taken from dictionaries, and one I've heard just more broadly. Learning is the process of acquiring new understanding, knowledge, behaviours, skills, values, attitudes, and preferences. Do you agree with that one? How does that relate to maths? All right. What about learning? Is knowledge acquired through study, experience, or being taught? Okay, so you see that one's a bit tighter. It's just about knowledge, whereas the other one was about behaviours and skills and things like that. To me, that looks like what maths is when I went through school. You notice that learning happens not just through being taught, but acquired through study or experience. Because we know we learn a lot of things without being taught them. Well, here's another one which I've heard a few times. Learning is the process of transferring knowledge from the teacher to the student, bypassing the brains of both. Is that what school experiences look like for you? Hopefully that's not what the school experiences will look like for the students you teach. Now, there's lots of ideas and there's nothing wrong with, well, at least the first two there. But I'm going to give you a different view. And the thing about all these ideas about learning is, in the end, we don't really know the answer, but we have theories or ideas. And so I'm going to give you another idea, and it doesn't give you all the solutions. It's just another way to think about learning. So see what you think about this. So my view is that learning is always a process of becoming stirred into practices. So by being stirred into practices, I mean practice might be a broad practice like mathematics, or it might be a narrow practice like how to factorise an equation, or it might be how to draw a pie graph. But it's always about being stirred into those practices, learning how to go on in those practices, which to me implies more than just putting something in someone's head. So we learn, in my view, we learn not only knowledge embodied in our minds and bodies and feelings, but also how to interact with the others in the world. So learning is not just an individual thing, it's also about how we relate and go on with others. Learning is not just situated with where we are, and I'll give you an example of that in a minute. So in other words, learning is bigger than just the individual. It always positions and orients us to shared three-dimensional semantic, material and social world. All right, so semantic means language. It positions us in terms of language and way we can talk and engage and think about things. Material just means physical things, time, space, the things around you. And the social world is the people we interact with, our relationships. Now that might sound a bit airy-fairy for you at the moment. I hope if you get a chance to stop and reflect on that and see what you think. Importantly, it just means learning is more than just putting knowledge in your head, because where we learn it, who we learn it with, where we learn it all makes a difference. So what does this mean? Well, learning mathematics is complex, and I don't mean just complicated. So by complex, I'll give you an example. A clock is complicated, but if you had an analog clock, you could pull it apart and put it back together again. Something that's complex is something that you can't pull apart and put it back together in the same way. So a bunny rabbit would be complex. If you pulled it apart, you can't put it back together. And learning in mathematics is like that. It's entangled with a whole range of things. When you learn mathematics, it's entangled with the people in your class, the teacher in the room, the material you're looking at, the things you've done before. You can't pull those things out. And so when you look at learning and how learning occurs, it's not just between you and the student and what you put in their head. And what does that mean in simple terms? Well, the way you teach and learn mathematics, particularly you as a teacher, the way you organise and facilitate learning experiences for students, it needs to be responsive to the needs of the learners in any particular site. Now, a few things about that. You notice here that it's saying we start with the learners, not with the curriculum. The curriculum tells us what we want them to learn, but it's the learners who are the one who have to learn it. So if you don't start with the learners, you could be completely missing the mark, because it has to start with what their needs and requirements, what their prior things are they bring to it. Learning's about building on from what they already know and can do and understand and who they are. And the problem is this is different for every kid in every class and every school site. So what you might do at TSS down the road here from the Gold Coast campus would be completely different than what you might do up in the North Cape if you're dealing with students there. They have different experiences of the world, different resources they bring to it, and so their learning needs are different. And even though you might be teaching the same curriculum, what that learning looks like might be different. As a teacher, you need to be responsive first to the needs of your learners. So this means that learning maths is site-specific. Any class I'm teaching, whatever they're learning, I have to be responsive to those students in front of me at the time. And the curriculum can give you a broad idea of the things you should be teaching, but you always have to make that relevant and that learning specific to those students in front of you in that site, in that classroom, in that school, in that community. I'll give you an example. We did a project where we went up to the Kimberley Ranges and we worked with some students in Aboriginal schools in remote communities. And what we did was we gave them NAPLAN questions, and almost invariably they got them wrong. And so then we tried to give this a question about the same idea in a context that they would be more relevant and more comprehensible to them. I'll talk a bit more about that in a sec, but we asked all the students, how far is it to the river? So this community was quite close to the Fitzroy River, and we just said, how far is it to the river? Now, every single one of the students in that school, and we did every student from about grade 2 to about grade 6, every single student gave us a reasonable and accurate answer to that question. Not one of them used the SI units for length, i.e. metres or kilometres. Right, what did they all answer? Well, they said 15 minutes, 16 minutes, 13 minutes. They all gave us an answer in terms of time. Now, if you think about it a little bit, if I said to you, how far is it to the airport? it's likely that you would say to me, oh, it's about half an hour. You wouldn't say to me, it's 22 kilometres or something like that. So this is a common practice that we do all the time. These students had learned about measuring distances, and they'd learned to measure it in this particular context in terms of time. And they could all measure the distance fairly accurately. The problem is every single kid would get that question wrong on a NAPLAN test because they didn't say how many metres it was. So you can see how they'd learned something, and they'd learned it really well and really accurately, but in this site they'd learned it in a particular way which didn't resonate with the formal things of the NAPLAN test. And so of course the NAPLAN test said these kids were dumb even though they were very smart. Another example from the Kimberley community, we were there was a shop in the community, and we said to the students, what's to the left of the shop? And every time we asked this, these kids would duck their head and they wouldn't answer. And every single one of them did this, and I asked all of them, and then so eventually I asked one of the Aboriginal support workers there, I've been asking these kids this question and none of them answer the question. And he said, what's the question? I said, what's to the left of the shop? And he ducked his head and didn't answer. I said, no, can you tell me? I really don't understand what's going on. And he said to me, well, you're asking a stupid question. I said, what do you mean? And he said, well, what's to the left of the shop depends on what side you're standing, where you're standing on the shop. If you ask the students what's to the north of the shop, what's to the south of the shop, or something like that, they would all answer you. But because they think you're asking a stupid question and you're supposed to be a smart person, they don't want to embarrass you, so they don't answer. So you see again, these students had very clear and refined understandings of directions and orientations of things. Just the context of which it was asked was different in that site. And so it was a matter of asking the right question. If I wanted to know about left and right, I should say, what's the left-hand side of this piece of paper, or something that doesn't matter which way you turn it around, it's always on the left. So they're just a couple of examples where the site actually makes a huge difference to what's learned and how it's learned. It's not separate. So I'll give you an example here of something that may be more familiar to you in a regular classroom. Let's say we want to ask students to find the area of a rectangle. The goal is to learn about areas of rectangles. So how could we start? Well, we could start by saying, well, what's the area of this rectangular space? Let's say a classroom. And then through dialogue and experimentation, the students come to understand that about area being the space in something, and about standard units. They learn to be able to measure lengths and calculate the areas. They learn to appreciate the value of mathematics standard practices. Okay, so why do we use SI units rather than just any random units? And they learn to understand the relationship between area, length and breadth. Now that doesn't sound probably too different to what you've already done, but you can see it's not here about just saying the area of a rectangle is the length times the breadth. Here's an example. Now do 10 of these exercises. It's about having a discussion and working through it so they understand the concept, and then all these other things get stirred in. The language of what they need to do, the relationship between things, the mathematical norms of working things out. And through that they learn to understand these things, and they learn to be able to, they're stirred into the practices of finding an area of a rectangle, and they learn to go on it so they can then go and do it in other ways, in other places. And they can find the area of other rectangles and hopefully then possibly relate this to areas of other shapes as well. So you notice by doing it this way, and again that's a really quick and brief explanation of it, but they're also stirred into being mathematicians because they can understand the appreciation of the limits of accuracy within measurement. They can understand how different measures are appropriate in different situations, and they can learn to value mathematical tools and how they're used. For example, meter rulers, and maybe when we start the kids would step it out or something like that. So they'd learn to value it, so then they can communicate with one another because so they can get the comparable results. So they can talk to one another about what they've found out. So this is more than just knowing the formula for an area of a rectangle, which they will learn as well. It might take them longer to get there, but once they've got there, they understand it and they can go on using these practices and become more mathematical in their thinking about area, rather than just regurgitating the formula and applying it to set problems that they already know. And in this way, they're affective, their emotions, their motivations, their beliefs and values, and their psychomotor responses, so their physical movements, are seen as an important and integral part of the learning, not just something on the side. So it's not like we teach them the maths and then try and help them to like it. Their values and liking and engagement with it is all part of the task. Now the important thing to note is whichever way you teach them about the area of a rectangle, the only way they can show you that they know something, i.e. how to work out the area of a rectangle, is in practice. In other words, we can't see what's in someone's head. The only way we know if they've got something in their head, i.e. how to calculate the area of a rectangle, because they'll practice something, they'll do something and show us. So in the end, that's why I think I try and focus not so much on what might be in their head, although obviously we're trying to help them to know stuff, but what they can do and practice and in meaningful ways. Now that's a really quick example and overview of quite a complex theory and way of understanding learning, but I hope you can engage with it, and it's a way of trying to help you understand it. I just want to look briefly now at what schooling has done to learning. So we know people learn stuff in all sorts of places, but mostly they think they only learn stuff at school, which is not true. You learn more before you turn 1 than you probably learn in the rest of your life. I'm not sure how they measured that, but it seems to make sense. But what happens is mathematics is all around us and everywhere, but now we have a school subject called mathematics. And what this tends to have done is valorize mathematical content knowledge. So in primary school, if you know your times tables, you know maths. Even though that's just such a minute part of mathematics, and in lots of ways it's not even that mathematical. But we've made really important mathematical content knowledge at the expense of its being practiced and used in meaningful ways. In a sense, we've removed learning from the community of mathematical practice. So where's mathematics actually practiced? Well, in universities, of course, mathematicians practice it as they do their work and their research, but people like engineers or people in trades, they practice their mathematics in the site where they're working, but even everyone uses mathematics every day. When you're driving your car, you're using estimation so you don't slam into the car in front of you, although sometimes you wonder some of the people on the road whether they're that good at estimating distances, how close they might get behind you. But by doing maths at school, we've removed it from where it's used all the time. And so by design, what you learn at school has become abstract. It's removed from practice and it has to be general. And of course, if you do that, it's built on the assumption that what you learn at school will be transferred to other contexts as required. So it'll be silly that if everything we learned at school was only just for school. The reason you learn stuff at school is so it can help you go on in mathematics, can go on in science or other areas of schooling, but it can also help you in your life and your career and tasks like reading the newspaper and things like that, right? Because that's the assumption of it. Whatever we learn at school, we assume that students will be able to transfer that to other places. Now the problem is, we know that school learning is not just generalised, it's actually learned in a site. It's learned in a school site. And what happens is it becomes so site-specific that it then becomes difficult to learn it elsewhere. So the very function of schooling to try and help students learn knowledge and practices that will be useful is somehow defeated by the fact that we learn it at school in such a tight structure. Now, the reason that maths learning is general as at school is important because we can't teach specific practices outside of school because we don't know where people are going to go and what they want to use it for. We want things that are general so then they can apply it in a range of places. But again, the point is here that if they learn something, it has to be able to be applied in other places. And the problem sometimes is it becomes so caught up in the school context that they can't apply it in other places. So Jean Lave, who's a famous researcher from the 80s and 90s, she investigated learning in a range of contexts, but she said learning transfer is assumed to be the central mechanism for bringing school-taught knowledge to bear in life after school. In other words, what we learn at school, we have to be able to transfer to other places. But the problem is, learning that people do at school doesn't seem to be transferred. In fact, if you ask kids about mathematics learning at school, they say it's useless, irrelevant, they're never going to use it again. So this is an important problem, and one that we haven't dealt with very well in maths education. So one of the things when we learn maths at school is students have to learn how they can then transfer that learning to other places. It's not good enough just to learn it at school to be used at school and then not relevant anywhere else. All right, so this is the issue again. Why do so many students finish school think that mathematics is dull, hard, useless and irrelevant, i.e. not transferable? So it becomes captured in school, parceled up in a little box and left there in their history that they never go again once they move on. So what does this mean for you as a teacher? If the purpose of mathematics education is to learn how to go on in mathematics, then learning how to mathematics is important, but learning how to go on in maths, i.e. how to be a mathematician, is actually the key goal of what you're doing. Your job is not just to teach them to maths at school, but it's about learning so they could go on and use that mathematics in a range of ways outside of school. It's not just about thinking or knowing cognitive knowledge, but about also mathematical practices. And if learning is more than just learning content knowledge or acquiring a body of knowledge that may be applied, it has to be taught and learned in ways that are active and that help students engage in the substantive practices of mathematics, so then they see it more as something that's seamless across their schooling and the rest of their life. It also means if mathematics learning is situated, then when we teach students at school and assess them at school, then we need to make sure that it's seen as something more than just a school subject. And often what happens is when we, particularly through assessment, is we restrict the mathematics we teach to that which we can measure or in a test. So therefore some of the things we don't necessarily teach very well at school are things like estimation or measurement, because in practical senses these things are not easily assessed through a test. So the assumption that learning is automatically transferred is just not viable or reasonable. It's something you as a teacher have to actually do. Now I've given you a whole range of ideas here. I haven't gone into great depth, but I just want to prompt you to think about learning in different ways, how you might help students learn. And I'll give you some more specific examples in the second half of this week's lecture, but here's some questions for you to ponder. So there's no YouTube clips for you to go away and look at, but here's some questions for you to think about. How can you learn to go on in mathematics? Why is it important for you as a teacher of mathematics? And in the end, how might you develop mathematical experiences that ensure that students can go on in mathematics? Okay, I hope that was interesting and challenging for you. In the second half, I'm going to talk a bit more about how kids learn in maths, and hopefully it will give you some practical ideas to put some meat around these ideas. All the best.